Hey there, and welcome to today's Explainer. We're going to be exploring a totally fascinating and honestly kind of mysterious process that's happening all around us, literally every single day. Have you ever actually stopped to wonder how everyday things, like fallen leaves in the yard, tossed out food, or even massive fallen trees, how they just break down and eventually seem to disappear into nature? Well, it's not magic, and things definitely don't just vanish into thin air. Actually, it's the result of a massive, completely unseen workforce operating right under our noses. So today, we're shining a spotlight on these invisible agents to figure out exactly how they recycle the world around us.
All right, let's just dive right into it. We've all seen a piece of fruit looking a lot like this severely rotted apple. And it's super easy to think of rotting as just something passively going bad, sitting on the counter. But that couldn't be further from the truth. This rot is an incredibly active process. Every single one of those powdery-looking spots you see is actually made up of millions of cells of microscopic fungi. Yep, millions. We commonly call this fungus mold, and they are actively consuming that apple, working away around the clock to break its structure down completely.
And that active process brings us to our very first core concept, which is decay. Decay is the specific process where microorganisms change an object, causing it to rot and break down. Now, what's really mind-blowing about this is the sheer scale of where these microorganisms actually live. They don't just magically show up out of nowhere, they are absolutely everywhere in our environment. I'm talking everywhere. They live in the air we breathe, in the soil we walk on, suspended in the water, and yes, they're even living right now on our skin and inside our bodies. They're just our constant, invisible companions waiting for the perfect conditions to get to work.
So what do we actually call these invisible culprits behind all the rot? Well, they're known as decomposers. A decomposer is an organism that makes things decay by directly feeding on them. You can really just think of them as nature's active, totally essential cleanup crew. Seriously, without them, our world would look incredibly different. By feeding on materials, they physically and chemically dismantle them, ensuring that the tiny components that originally made up that object are broken apart and recycled.
Now, while there are a bunch of different types of decomposers out there, when it comes to the microscopic ones driving the decay we've been talking about, we're primarily looking at two main groups. That's bacteria and microscopic fungi. These guys are the heavy lifters of decay. When you think back to that rotting apple from a minute ago, it was these microscopic fungi actively breaking down the crisp, fresh fruit and transforming it into something soft, brown, and totally unrecognizable. They feed on it, and as they feed, they literally change its very nature.
So the crucial point here is understanding exactly what these decomposers will actually eat, because they don't just eat any random thing they come across. Decomposers have a very specific diet. They feed strictly on organic matter. By definition, organic matter is any substance that has been made by a living organism. Basically, if it originally came from a plant or an animal, it's organic matter. And if it's organic matter, well, it is basically an all-you-can-eat buffet for our microscopic friends.
All right, let's test how well we understand this concept with a quick little interactive moment. Think about these everyday items: bread, water, leather, rock, wood, and fruit. I want you to think critically for a second about where each of these items originally comes from. Based on our definition, which of these everyday items are made of organic matter? Take a second to mentally sort them. Which ones were made by a living organism, and which ones weren't? Okay, let's see how you did. In the organic matter group, we've got bread, leather, wood, and fruit. Why? Well, because bread comes from wheat, which is a plant, leather comes from animal hide, wood comes from trees, and fruit obviously grows on plants. Because they all originated from living organisms, microorganisms can and absolutely will actively break them down. On the flip side, in our not organic matter group, we have water and rock. These were never alive, right? And they weren't created by a living organism? So our microscopic cleanup crew has absolutely zero interest in them as a food source.
To make this perfectly relatable, let's think about one of the most common examples of organic matter decay you might actually find in your own home. It's a total classic scenario. A piece of bread may be forgotten in a school lunchbox for, well, let's just say a little bit too long, and now it's sporting several fuzzy patches of blue mold. Because bread is packed with organic matter, the remnants of those wheat plants, it provides the absolute perfect fuel for microscopic fungi to thrive. The mold is literally digesting the bread right there on the crest.
And zooming in brilliantly illustrates what is actually happening up close. If we take that exact same blue bread mold and magnify it through a microscope, it completely shifts our perspective. From far away, it just kind of looks like blue dust or fuzz, but under the microscope, you can see that the fungus is actually made up of this intricate, tangled network of tiny threads. These delicate little threads spread out, penetrating the bread, releasing chemicals, and absorbing all those nutrients so they can grow.
Now that we know what these invisible agents are and exactly what they eat, the next logical step in our explainer is to put on our scientist hats. If decomposers are living organisms, they've got to be affected by their environment, right? So we're going to set up an investigation. Our primary question here is, how does temperature affect decay by microorganisms? Does heat speed them up? Does cold slow them down? Let's figure out how we can structure an experiment to find out for sure. Here is exactly how we can test this. And remember, the key to any good experiment is controlling our variables. Step 1, we start with 2 similar pieces of bread on 2 plates. Step 2, we add just a little bit of water to both, making sure not to soak them, just get them slightly damp. Step 3, we leave them open to the air for about 30 minutes. Why do we do that? To allow all those microorganisms naturally floating in the air to land right on the bread. Then, we seal both plates tightly with plastic wrap. Finally, step 4 is where we introduce our change. We put one plate in a nice warm place and the other in a cold refrigerator. Oh, and a super quick safety note here for any budding scientists, once that plastic wrap goes on, you should never ever uncover the bread later on, because you absolutely do not want to breathe in those concentrated mold spores.
So, by observing the bread over several days, we can gather some real concrete evidence. Think about what you already know about temperature and living things. What's your hypothesis here? Would you expect the bread in the warm environment to show more colonies of those blue mold threads, or the bread sitting in the cold refrigerator? By comparing the results of these 2 very specific environments while keeping the bread and the moisture exactly the same, we can confidently conclude exactly how temperature impacts the speed at which our decomposers feed and grow.
But here's the thing, temperature isn't the only environmental factor at play. Think back to step 2 of our last experiment. We specifically added a little water to the bread. And that brings us to another totally critical element for microbial life, moisture. Just like us, microorganisms need water to survive and function. So having tested temperature, a scientist would immediately pivot to planning a second investigation. How exactly does the amount of moisture affect the rate of decay? Let's see how this builds out our scientific framework. To test this new factor, we first have to state our hypothesis. Moist bread decays more quickly than dry bread. Pretty straightforward. But to prove or disprove this, we have to conduct a fair test. The only variable we are going to change this time is the amount of moisture. For instance, one piece of bread gets sprinkled with water and the other stays completely bone dry. Crucially though, all the other variables must be kept exactly the same. They both need to be the exact same type of bread, kept at the exact same temperature, and exposed to the exact same amount of light. Because if we don't keep those variables identical, we won't know if a difference in decay is actually due to the moisture or just something else entirely.
Which leaves us with a truly massive thought to close on today. We've seen how microscopic fungi and bacteria actively dismantle everything from fruit to bread, feeding specifically on organic matter. We know they're constant, they're invisible, and they're deeply affected by things like temperature and moisture. But consider this massive question. What if they just stopped? If every single decomposer in the world suddenly went on strike, what would happen? Well, every leaf that ever fell, every apple that hit the ground, every fallen tree would just stay there, forever. Without these invisible agents of decay, our world would literally disappear under miles and miles of perfectly preserved, dead organic matter. So decay isn't just about things going bad. It is the ultimate, essential recycling system of our entire planet. Thanks so much for joining me on this explainer, and honestly, I hope you never look at a moldy piece of bread the exact same way again.